Hi, and welcome to Weld.com. My name is Chris King, and I'm the Director of Skill Training for Campbellsville University. I was asked to go through and watch some videos, watch some of Weld.com's videos on YouTube, and I was scrolling through them and looking at them and reviewing them, and everything looked great. And I just happened to come upon one about arc blow. So I watched it in its entirety.
So today we're going to talk about a couple different ways to get rid of arc blow or mitigate it completely. Let's go ahead and start off with the first one.
And I think I learned something. So we're going to see. In 31 years in the welding industry, I've been dealing with arc blow my entire career, just as any other welder has. We all have to come up with creative ways of working with that and fixing that. So I had made mention that if it actually works, I did learn something. In my experience, I've never seen the tips and tricks and stuff that we're going to cover here today. I have my own little ways of doing it, but we're going to test it. We're going to test ourselves out here and see if it actually works. It works for them, so we're going to test it out here today and see if it actually works. We may even learn something. We're going to talk about arc blow, different types of arc blow, what causes it, and how to hopefully prevent it from happening to you. So the two different types of arc blow. There is thermal arc blow and there is magnetic arc blow. The thermal arc blow is pretty simple. It's just the fact that your arc does not want to leave the hot zone. So when you're moving your puddle into cold metal, that arc does not want to leave the heat of the weld pool. So it will the arc tends to try to lag behind. This is more common in mechanical processes, mechanical welding processes where the travel speed is really fast. It does happen in manual. If you're trying to travel too fast, your arc is going to try to lag behind you and try to hang on to that hot spot in that weld pool instead of moving along into that cold metal. So that's thermal arc blow. That's pretty easy to take care of. You can adjust that in travel speed and whatnot. So the one we're going to be talking about, concentrating on today, is magnetic arc blow. So magnetic arc blow is a phenomenon that happens in the welding process. So I have some V grooves set up here today where we're going to actually experience it. I've already welded one up. So if you notice right here, I've welded one up and I got about 2/3 of the way up it. And sure enough, my arc went all to pieces and started jumping around. The weld pool just completely disappeared and it was acting really silly on me. So I know what that is. It's magnetic arc blow. So we're going to get into that, and I'm going to weld one up, and I'm going to try some different things and just experiment just a little bit. We're going to try to verify the tips that I saw on the previous video. So I think this will be fun. I think we'll enjoy it. Hopefully we'll all learn something here today, and if this works, I'm going to be using this from now on. All right, so now what I'm going to do is I'm going to show you a little bit. I have a rudimentary drawing. It's just a simple little thing, kind of crude, but I want to give you a basic idea about how the electricity flows through your welding rod and through your plate and what it is that exactly causes magnetic arc blow. Now, a lot of people talk about magnetic arc blow in one way or the other, one direction or the other, but you can actually, depends on what position your plates are in, you can actually get arc blow running either way. There's actually forward arc blow and there's back arc blow. So what we're going to be experiencing here on this plate, more than likely, what I did on this first one, that was back arc blow. So it's going back away from my direction of travel. So I'm going to explain that just a little bit right here. So I've got the lines drawn on here that kind of shows you how the magnetic field flows through this plate. So you notice these lines right here that have some distance between them. That represents a nice equalized magnetic arc field or magnetic flux. I'm not talking about the flux on the welding rod. That's the magnetic flux. And it's nice and equal, and the distance between them will be nice and equal. That means that that is stable. That means that magnetic field is stable in that plate. Now, if you notice up here at the top, the closer I get to the top, and I started that about where you're going to start having issues with arc blow, notice those rings get a lot tighter, and notice that they're a lot closer together. The reason that is because the magnetic field is being pinched. So the magnetic flux is actually being pinched right here, and it causes magnetic pressure to build up right here in this area. So what magnetic arc blow does is your arc is going to try to go back down to this area where your magnetic field is stable. It's being really interrupted up in this area, so it's trying to compensate for that, and it's going to try to make its way back down to here. That's why you lose your arc. That's why your puddle goes all to pieces. That's why you lose controllability of the puddle. And it's best at that point just to stop, because once you start experiencing arc blow, you really can't fix it unless you uh, incorporate some of the tricks that we're going to show and talk about here today. You can't really fix that. You might as well just stop. And once you've experienced that, that's going to be a nasty spot in your plate or in your weld. Take a grinder and clean it up and just start all over. Make some corrections, make some adjustments, and start all over and finish that weld out. In this one over here, the arc was very stable and it was flowing beautifully as I was going up the plate. And as soon as it reached this point where that magnetic flux was being pinched and that magnetic pressure was being built up, that's when my arc went all to pieces. So it started rolling out on me. My droplets out of my filler rod started going to different and erratic places, and it just didn't flow. I lost my puddle, lost all controllability. The arc was jumping back and forth, so and just lost it in there. So that was magnetic arc blow that I experienced in that. So what I'm going to do now, we're going to weld this one up, and I'm going to do one of my tricks, one of my solutions for it that I've always used, and that's simply just moving your ground clamp to a different position, and we're going to try that and see how it works out. All right, so what I'm going to do now is I'm going to weld this middle one up right here. And this is just basically what I do. So if I experience arc blow up here, I had my ground clamp on this first one. I had my work clamp clamped directly to the table and quite a bit of distance there. So I just took my work clamp and hooked it directly to this piece that I'm getting ready to be welding on. I hooked it to the top. Typically, if you hook it at the bottom, uh, sometimes it works, sometimes it don't. So that part of it I can't explain. But I have a lot more success with hooking my work clamp directly to the top of the plate. So let's weld this one up and see what happens. All right, so let's clean this one up. I just ran that one. Didn't feel any kind of arc blow, any kind of destabilization of the arc. So let's chip it off and see what it looks like. So I didn't get any arc blow at all. You can see in this weld, it's just as stable as it can be going all the way up. So like I said, that trick works for me in general, but there are certain circumstances where that's not going to be an option. Um, if you're working out on the job, you may not have the option. You may have 150, 200 feet of lead pulled out. You're not going to want to pull out 200 feet of lead of your stinger and your work clamp. So your work clamp may be way away from you. It may be on the other side of the of the building or whatever. You may not have that option of hooking your work clamp directly to the plate that you're welding on, or the weld you're making, or the joint that you're welding together. So this is not always an option. It works in situations like this for test plates or small welds where you're right there in the area, in the vicinity of where your welding machine is at. That works out great. So let's set up. So in the video, it shows a new trick that I didn't know, I wasn't aware of. Like I said, I've been in this industry a long time. I've traveled on the road. I've been on work sites. I've been in manufacturing plants. I've been in several different aspects of the welding industry. And fighting arc blow is just a thing you do. And in all my experience, I'd never heard of this trick, and I don't know how I missed it. It just avoided me for some reason. But I'm watching that video, and what they showed in the video was this trick. So this is just two ground clamps, and it's got a set of it's got a copper lead in between them. It's about 18 inches long in between them. And what they showed in the other video was hooking one at the bottom of your plate, hooking the other one at the top of your plate, and that's going to solve your arc blow problem. So we're getting ready to put that to the test. I want to see if it works as efficiently as they claimed it did, and if it does, then hey, this is going to my truck. This is going with me wherever welding that I'm going to be doing. I'm going to be taking this with me. Going to be showing it to the students here at Campbellsville and letting them use this little trick. So let's hook it up. So according to the video, you hook one at the bottom on the right side of your plate. You hook the other one on the top of the opposite plate, and that's supposed to help your arc blow. Now, I was really confused that this isn't hooked to anything. This isn't hooked to any machine. It's just two ground clamps hooked together. But as you start thinking about what arc blow is, you start thinking about how it affects how that magnetic pinch, that flux pinch happens. Once you start putting that all together, I can kind of understand how this would work. So let's see if it does. All right, I'm going to weld this one up that we were talking about. We've got this set up. According to the last video, this is supposed to work, and I'm not supposed to get arc blow. So you notice I moved my ground clamp back down to the table. So that's the way I had it when I welded the first one up, where I experienced the arc blow. So I don't want to give away any kind of uh, leeway to this actually working, whether this works or not. So I've moved my ground clamp back down, and I just have this loop of copper in between the ground clamps. I have this looped on this plate. So we're going to weld it up and see what happens. So it's running pretty smooth right up where I would experience arc blow on the other one. So I've made it all the way up this plate and up into the backing strip with zero arc blow. So that was pretty smooth, I have to say. I do want to mention that I'm using the Bowler Fox EV50 8th inch 7018, very smooth rod, very good arc stability. Stabilizers in the flux are phenomenal. One of the smoothest running rods that I've used. So appreciate Boulder for sending those. And let's ship this off and see what it looks like. All right, so chipped and brushed. That's what we've got. No arc blow. Really smooth transition all the way up that plate. So I'll give my new little work buddy here a thumbs up. So I did want to mention also another trick for taking care of arc blow is you can switch your machine to AC because alternating current, it alternates between positive and negative. That alternation of the current, it kind of interrupts that magnetic arc blow. It kind of interrupts the arc pinch or the magnetic pinch. So it kind of keeps that stable all the way up. You may not always have the option of running AC. If you're running code work and the WPS was written for DC current, that's an essential variable. So according to the code book, you can't switch that to AC and run it. If you switch an essential variable, if you change it, then you have to go back and requalify that process. You have to start all over, write a new procedure, PQR, and the whole 9 yards, test it. So inspector's not going to let you mess with that essential variable, so you may not have that option. But that is an option if you're farm work, shop work, whatever, and you're having real bad arc blow, don't have access to any of this, switch your machine over to AC, and it'll take care of it for you. I give this a thumbs up. Like I said, I think it works, and I've learned something. Hopefully, you've learned something, and I appreciate you watching. And hit that little subscribe button down there if you like what you see, and we'll see you next time.